Okay, this is the homework problem actually from Thursday night that we started on Friday, but I'm going to start from the beginning for those of you who didn't understand what was going on. So this was the function that you got, and the first thing was you needed to find f prime of x. So first you want to get this into the correct form, and then take the derivative. So remember they said that k was a constant, so you're going to bring down this 1/2 and multiply it by k, which just gives you 1/2 k, x, and then you're going to do 1/2 minus 1. So 1/2 minus 2/2 is a negative 1/2. Minus the derivative of ln of something is 1 over that something times the derivative of the something, but the derivative of x is just 1. Okay, so that was the answer for part 1, and part 1 of A. And if you wanted to simplify that, you could, because this k stays on the top, the 2 is still on the bottom, and then x to the negative 1/2 means it moves down to the bottom and gets a square root. Okay, and then minus 1 over x. So that would have bought you 1 point. Okay, then you need to find f double prime of x. So in order to find the derivative, I'm not going to use the simplified version. I'm going to use this version right here because this will be easier for me to find the derivative. So I bring down the 1/2, negative 1/2, and I multiply by a positive 1/2. That gives me a negative 1/4. K just stays there because it's a constant. X, and then a negative 1/2 minus 1 is negative 1/2 minus 2/2, which is a negative 3/2. Oops. Okay, minus, and now you have to do the derivative of 1 over x. So keep in mind that 1 over x is the same thing as x to the negative 1. So you're going to bring the negative 1 down, so the negative and negative gives you a positive, x, and then a negative 1 minus 1 is negative 2. And so that would have just bought you 1 more point. Okay? All right, now, I'm going to go to the next page. Okay, we're going to do part B. So part B says to find the critical point, but they're actually telling you that the critical point is when x equals 1. So you're going to have to figure out what k is. So all you should really pick up from that piece is where's the critical point. So you find the critical point when the first derivative, which was this, is equal to 0. That's how we find a critical point, by setting the derivative equal to 0. Okay, so what we're going to do is we're going to take this negative 1 over x and bring it to the other side. So now everything becomes positive and it's nicer. Okay, now I'm going to cross multiply and get kx equals 2 radical x. Okay, but you were told that x equals 1. So now we're going to substitute 1. So we're going to have k times 1 equals 2 times radical 1. Well, k times 1 is obviously just k. Square root of 1 is just 1. You do not have to consider negative 1 because they told you at the very beginning that x has to be greater than 0. So the square root of 1 is 1, and 1 times 2 is 2, and therefore k equals 2. And that was 1 more point. Okay, now the next question is, okay, so if there is a critical point at x equals 1, so they already gave you the critical point as at x equals 1. Is this a max? Is this a min? Is it neither? So 2 different ways that you can do this, and I'll do them both ways. So the first way you could do it is by making a wiggle graph. So we make a wiggle graph, and we're going to be testing into f prime. Something just happened to my screen. There we go. Into f prime, and you're going to put 1 on there. Now, as long as you see a sign change, that means that there is definitely a critical point. So just keep in mind that this part over here, this was our, this is our derivative right here. So you're going to take a number that is smaller than 1 and you're going to substitute it into the derivative. So you cannot do 0, because if you put 0 in there, you're going to get 0 in the denominator. And you can't pick a number smaller than 0 because they said that x has to be positive. So unfortunately, you're going to have to do f prime of a fraction. So I'll do 1/2 because of all the choices. That's probably going to be the easiest one. Okay. So what do I get? I get k, which is 2, over 2 times radical 1/2 minus 1 over 1/2. So these 2's cancel, and you're left with 1 over square root of 1/2 minus, if you have 1 over 1/2, that just becomes 2. Okay, so you have to decide, is this going to be positive or negative? And the square root of 1/2 is going to have to be smaller than 1. So this whole thing is going to end up being a negative number. You don't care what it is as long as it's negative. Obviously, if you have a calculator, you can do it on the calculator. Okay, so now we have to check a number bigger than 1. So let's check when x is 2. So I'm just going to make room over here. Okay, so we're going to do f prime of 2. This is driving me batty that the screen keeps getting smaller. Okay, f prime of 2. So now I'm going to substitute into this thing right here. So I'm going to have k, we said k was 2, over 2 times radical 2, I'm putting this 2 in there, minus 1 over 2. Okay, so if we simplify, these 2's cancel, and I have 1 over radical 2 minus 1/2. Now, obviously, radical 2, when you compare a radical 2 and a 2, radical 2 is a smaller number. So therefore, negative 1/2 is the bigger number, and you're going to end up with a negative. Okay, I'm a complete idiot, because 1 over radical 2 is actually 0.707, which I should have recognized right away because that's the sine and cosine of 45 degrees. So going back, so, oops, let me take this out. Okay, so 1 over radical 2 is something like 0.7 minus 1/2, which is like a 0.5, so that actually is positive. Okay, so as you can see, there's a sign change there, and so if there's a sign change, there's definitely a max or a min. Okay, so which one is it? Well, over here, the function was first decreasing, and then it was increasing. So if you go from decrease to increase, there must be a min. So your explanation for this, if you're doing it using the wiggle graph, is you would say, by the first derivative test, there is a relative minimum at x equals 1. You can't just say there's a relative minimum. You have to state it's at x equals 1, because f prime goes from, what do we have? Decreasing. Okay. From decreasing to increasing. So the magic words here that they are really looking for is the first derivative test. You cannot say by the wiggle graph. You're saying by the first derivative test, and you have to say something like it's going from decreasing to increasing, or because there was a sign change. Okay, so that was one way to do it. Now I'll show you the other way to do it, which is the way that I did it in class. Okay, just because that was kind of time consuming because you had to put like annoying numbers into the first derivative. So instead, there's something called the second derivative test. And the second derivative test says if f double prime of x is greater than 0, there's a min. So just remember that it's the opposite of what you would think. If it's greater than, you would think there's a max, but actually it's a min. This happens because if it's greater than 0, the second derivative is greater than 0, it's concave up, and there's a min. And the other part of that rule is if f double prime of x is less than 0, there has to be a max. Because if it's less than 0, it's concave down, and therefore there's a max. So what you can do is you can use your second derivative, which you've already found anyhow in part A, and you could put 1 in there and see what that gives you. So for the second derivative was negative 1/4 k, but we know that k is 2, x, which is 1, to the negative 3/2, plus x, which is 1, to the negative 2. Okay, now we have to do is simplify. So negative 1/4 times 2 is negative 2/4, which is the same thing as negative 1/2. And then 1 to the anything will give you 1. So it's just negative half times 1, which is negative 1/2. Plus, again, we have a 1 to the anything that is 1. So negative 1/2 plus 1 is a positive 1/2. And we just said by the previous rule that if it's greater than 0, there is a min. Okay, so that's another way that you can show what it is. So what you would write for that one is, by the second derivative test, there is a relative minimum because f double prime of 1 is greater than 0. Okay? And so the magic words that they're going to want to see for this one is the second derivative test and the second derivative was greater than 0. Okay, so that completes part B, and now we have the last part, which is part C. Okay. So for part C, it's very wordy, but they're saying that there's a point of inflection. So let's just pick up on that and recall that there's a point of inflection when f double prime equals 0 and there's a sign change. Okay, so the second derivative looked like this. This we already found in part A. Okay, so how do you find an inflection point? You take the second derivative, which is what I just wrote here, and you set it equal to 0. Just by writing that, you just earned yourself 1 point. Oh, I forgot to give you the point values for part B. But let me go back and I'll show you what the point values were. Okay, so if you did this piece right here, setting it equal to 0, that got you 1 point. And then if you found that k equals 2, that was 1 point. Then in your justification, if you either said this, it went from decreasing to increasing, or if you said this part here, because the second derivative was greater than 0, that got you a point. And then if you were able to figure out that based on either one of those tests, it was a relative minimum, that brought you 1 point. Okay, now let me continue. Okay, so the second derivative set equal to 0. So I will tell you that I ran into a lot of trouble with this, but I'm going to explain why so you don't make that same mistake. So the first thing you want to do is rewrite this so it's a little bit nicer. So let's turn this into two nice fractions. And so the k goes on the bottom, the 4 goes on the bottom. I'm sorry, the 4 goes on the bottom, k goes on the top, there's a negative on top. The x is going to go on the bottom, it's a square root to the 3rd degree. And then this just becomes 1 over x squared. Okay, so if you are not good at algebra, and you look at this and you go, oh my god, this is a mess, then just move on, and if you have time, you come back and you play around with it. Because there's a lot of simplifying that you have to do. So the first thing that you have to consider, because if you don't, it's not going to work for you, is that the square root of x cubed is the same thing as the square root of x squared times the square root of x. So you'd have to remember your algebra rules. And then when you square a square root, you just end up with x radical x. So that was the first thing that you had to do, was to simplify this one part right here. Okay, so let's go back and simplify that. So you're going to have negative k over 4x radical x plus 1 over x squared. Okay, and these are all equal to 0. Okay, so I will say that I'm going to show you what I did. Don't bother copying this because it's wrong, but I just want to show you it's really important for you to see why it's so wrong. Okay, so the first thing I did was I brought that negative k term over to the other side so everything's positive, and I ended up with this. Because I wanted to get myself into a situation where I could cross multiply. So when I cross multiply, I get this. And now this is where this is where things just went really bad for me. Because I am supposed to be solving for k. And I can't solve for k because I have to get k alone. And the only way I'm going to get k alone is if I divide by x squared on both sides. Which would be nice, except that I have to always consider that x could be 0. So if x was 0, then I can't do that. Now, you might say in the beginning it said that x has to be greater than 0. Still, it doesn't matter. You just simply cannot divide by a variable ever. So I can't get myself into a situation where I'm cross-multiplying. And that took some time for me to realize I need to find another way to do that. So that was annoying. Let's get back to where we were. Okay, so rather than doing that, what I did was I said, well, if I leave it in the way it is now, set equal to 0, I can clear all these denominators by starting to multiply by things. So the first thing I did was I multiplied everything by x. Okay, so every single term has to be multiplied by x. And when I do that, I'm going to draw a little line here. If I multiply the first term by x, this x will cancel with that one, which would leave me a negative k over 4 radical x. And then when I multiply this piece by x, one of these x's will cancel, leaving me with 1x underneath. So plus 1 over x. And then obviously 0 times x is just 0. Okay, then the next thing that I did was I multiplied both sides by radical x. What I'm trying to do is get all variables away from that k. So if I multiply this entire thing by radical x, when I multiply the first term, this x is gone, and I'm left with negative k over 4 plus radical x over x, and radical x times 0 is just 0. Okay, then I used algebra, so I'll do this in a different color just to go over this rule, which says that like if you have x to the 5 over x to the 3, it's going to be x to the 5 minus 3, which would just obviously be 2. So I'm going to use that rule to simplify this to negative k over 4 plus x to the 1/2 over x to the 2/2 equals 0. So I chose x to the 2/2 because it's really x to the 1, but I wanted to have a common denominator with the x in the numerator. So what that just did for me is I could use that rule to say keep the base and then subtract the exponent. So 1/2 minus 2/2 is a negative 1/2 equals 0. And you can see slowly but surely it's starting to come together, but this was very time consuming. And that's why I'm saying, you have to make a judgment call. You see it's taking a lot of time, go on to another problem and come back. Alright, let's switch colors and make it a little more interesting. How about a nice bright yellow, like the sun, which is sort of out today, but it's kind of cold. Okay, so we have this. Now x to the negative 1/2 is really equal to 1 over radical x, so let's write it like that. Okay, clearly I can't stay with this yellow, so let's find a different color. How about this dark blue? Okay, so then the next thing I did was what the hell did I do here? I brought the negative k over 4 to the right side. Sorry about that, that was bad, I just said that. Okay, so I got 1 over radical x equals k over 4. Okay, now remember, if I cross multiply and I get k radical x equals 4, oh no, that was okay. Sorry, I'm starting to lose my mind now. Okay, so I got k radical x equals 4. If I just looked at my notes, I wouldn't have these problems. And then I divide both sides by k because the way you solve a radical equation is by isolating the radical. So I divide both sides by k. I think you should be impressed that I have the patience to go through all this. And then you're going to square each side, right? So I'm going to square this side, and I'm going to square this side. So when you square a square root, you're just left with what's inside, which is x. When you square 4, you get 16, and when you square k, you just get k squared. So if you did this part right here, you got 1 point. So you have to consider that was a lot of work for 1 point, whereas you might be able to get more points if you go on to another problem, because if you run out of time, all you got was 1 stinking point here. Okay, so let's go back to the question. For a certain value of the constant k, there is a point of inflection on the x-axis. Find this value of k. So all they told you here was this is the x value. You still need to find the k. So let me go to the next page. So let me just write that we just found that x equals 16 over k squared. Okay, so what you're going to have to do is you go back to the original function, which is f, and you want to do f of this x that you just found. Okay, so when you do that, I'm looking at the original function, which was k radical x. So k radical x minus ln x. Okay, so if you simplify a little bit, you will get, this is the most annoying feature of this program, that the window keeps changing sizes. Okay, you'll get k times, square root of 16 is 4, and the square root of, oh wait, I made a little bit boo-boo here, wait a minute, let me fix this. This was an x squared, it was k squared. Was anybody yelling at the TV about that? I don't know. I mean, I guess I should say computer, not TV. Okay, there we go. Okay, so the square root of 16 is 4, and then the square root of k squared is just k. So you get that minus ln of 16 over k squared. But these k's cancel, so you actually get 4 minus ln of 16 over k squared. Okay, so I really got stuck here, and I was like, okay, so now what do I do with this? I'm supposed to solve for k. And here was the little trick, because you know how I said they never give you information that you don't need? In the story, it says it has a point of inflection on the x-axis. And so why would they give you that if you weren't going to use it? So think about this. If this is your x-axis and there's a point on it, wherever it is, doesn't that mean that y equals 0 there? So therefore, this piece down here has to equal 0, because the point's y value is 0. Alright, once you get that, now it's not so bad. So I'm just going to move to the next screen. So we had this. Okay, so I brought the ln term over to make that positive. Okay, and Melanie Tucker, I know you're saying, where are your absolute value signs? I'm not worried about that because 16 is a positive number, and anything squared in the denominator would be positive, so I know it's positive. But I know you were thinking that. Okay, so remember we said that the way you get rid of ln is to create a base of e on each side. Okay, and then we can simplify, because remember that rule that says if there's a base of e here and a base of e here, and you know there's a base of e there because it's ln, then this entire thing is going to equal this part right there. So I get 16 over k squared. Okay, and so now I'll put e to the 4th over 1 and cross multiply. Okay, we're trying to get the k alone, so I divide both sides by e to the 4th. And then I can take the square root of both sides. And that was the final answer, and that was worth 1 point. So when you think about it, I started part C, I believe I was at 11 minutes on this video, and now it's 25 minutes. So that's 14 minutes that I just wasted for 2 points. It's really not worth it unless you immediately can, start doing this quickly and you finished all the other problems and you have the time to do it. Okay, so that's it. And Eleni, I know you're wondering what I'm having for dinner tonight. I'm making chicken sausages again. Getting a little sick of it, but whatever. Okay, and I guess I'll see you guys on Monday. Don't forget there's a test on Tuesday. Or Wednesday, did we say? Whichever day it is. It's Tuesday. We said Tuesday. Okay.